Hello everyone. This is a video on quantitative research, a brief video. When we're thinking about quantitative research, we want to look at the categories. And so to help you here, I have quantitative research at the type, and there are two different divisions. First, experimental research, then non-experimental research. The two different types of experimental research are, well, of course, experimental, but then quasi-experimental. And then the two different types of non-experimental research are descriptive and correlational. Now, moving on, first we're going to begin with descriptive research. Well, descriptive research describes a phenomenon, a situation, or a population. That's all it does. It describes. It can answer the what, where, when, and how questions, but not why questions. There is no control or manipulation of variables whatsoever. If we want to think of a particular study that might be descriptive, think of the study habits of graduate students. So we could spend, well, we could look at the number of hours you spend reading a textbook. We could use descriptive statistics and probably include the range of hours that you spend, the average number of hours, maybe the percentage of hours out of 24 hours. Now, you can see that because of this type of simplistic data and no intervention, I really can't do anything too complex with statistics. Now, what are the different types of descriptive research methods? Well, there's surveys, observations, and case studies. A survey allows you to gather large volumes of data that can be analyzed by frequencies, averages, and patterns. Observations allow you to gather data on behaviors and phenomena without having to rely on the honesty and accuracy of respondents. And a case study can be used to describe characteristics of a specific subject, such as a person, a group, event, or organization. Now, here's some examples of descriptive research. A description of the study habits of graduate nursing students. A description of the attitudes of nurses caring for morbidly obese patients. A description of medication errors of nursing students. A descriptive study of the continuing education needs of registered nurses. Now, next, we're going to look at the statistics that we use. Again, very simplistic. We use distribution, which is the frequency and the percentage. And so this is an example of distribution. Right here you can see that it gives us the percentage of the entire group. Frequency is really a count, like 5 people, 6 people, something like that. Now, we also have central tendency, and you've studied that. So look over in here at the data here, mean, median, and mode. And then we have dispersion, and you've studied that as well. Standard deviation, variance, and range. So that's what data might look like for a descriptive study. Now we have correlational data. Now notice this cartoon that I have over on the right hand side. I put that there. It is so important to understand that correlation does not imply causation. An example. The research that was done back in the 1950s and 60s on cigarette smoking and lung cancer was really only correlational research. They could see an association between smoking, secondhand smoke, and lung cancer, but they couldn't call it causation until they were able to study that further. Now, it measures a relationship between two variables without the researcher controlling either of them. Remember, again, correlation does not imply causation. Now, there's 3 different types of correlational research. You have positive, negative, and no correlation whatsoever. So the positive correlation is an increase in one variable leads to a rise in the other, as depicted in this first picture. And then also it could mean that a decrease in one variable will see a reduction in the other. So you can see that both of them are headed in the same direction. Increase in one, increase in the other. Decrease in one, decrease in the other. Negative correlation, however, you have the opposite. An increase in one variable leads to a decrease in the other, and a decrease in one variable will see a rise in the other, and that's depicted over here. Now, with no correlation, can you see there's no correlation here? The pattern of points or data. So a change in one variable may not necessarily see a difference in the other. There's absolutely no connection between the two variables. Now, again, what we can do here is the research methods could be similarly to descriptive. It could be a survey, naturalistic observation, similar to descriptive, but then we can also have secondary data. This is research data that was really obtained from another study, and now you're asking different research questions of the data, and you're looking at it to see what else can you learn from this data. Usually this is collected from official records, polls, again, previous studies. Now, here's some examples of correlational research. As height increase, weight also increases. You can see that's a positive correlation. As coffee consumption increases, tiredness decreases, a negative correlation. Coffee consumption is not associated with height. Well, that's no correlation. And then you have here a correlational research question. Is patient satisfaction linked to nurse-reported rationing of nursing care and to nurses' perception of their practice environment? Now, correlational research statistics that are used. We have the Pearson's correlation coefficient. I will tell you, we also have the Spearman-Rowe statistic. I'm not going to get into that because the most frequently used is really the Pearson-R or the Pearson correlation coefficient. Okay, so what we know about this is that it measures the statistical relationship or association between two continuous variables, and it gives information about the magnitude of that association. Sometimes I call that the strength, okay, or the correlation, as well as the direction of that relationship. Now, the strength of the relationship can be interpreted from the value of the correlation coefficient. Ranges from -1 to +1. The closer the R is to either the +1 or the -1, the more closely the two variables are related. And of course, 0 means no relationship. I put this little table here for you so you could see the strength of a correlation. So if it's 0.9 to 1, ooh, very high. 0.7 to 9, again, a high. And then 0.5 to 7, moderate, and you can see that there. Now, experimental research is the next one that we're going to take a look at. And experimental research is really considered to be the one type of research that we always think about when we think about research, right? So it strictly adheres to the scientific process. It includes a hypothesis. A variable can be manipulated by the researcher, and variables that can be measured, calculated, and compared. Now, most importantly here is that experimental research is completed in a very controlled environment, and it always has 3 characteristics: manipulation, control, and randomization. So remember those. Manipulation, what happens here is the experimenters do something to the participants in the study. When they have a control, the experimenters introduce controls over the experimental situation, including the use of a control group. And then with randomization, experimenters assign participants to either control or experimental groups, and they do so randomly. Now, it's at this point when we're talking about experimental research that we really need to understand the difference between dependent and independent variables. So that independent variable is the variable that is manipulated. Okay, it is the cause. Then the dependent variable is the outcome or the effect of the study. And I have this image over here to help you understand that. Now we also have control and treatment groups. So the treatment group is the one that receives the intervention, while the control group receives no treatment whatsoever. Now, often what people get confused is random selection and random assignment. And at this point, you really have to understand the difference. Random selection refers to how the sample is drawn from the population. I think this picture down here really explains it well. Here's your entire population, right? And so from that population now, you have a random selection of your sample. Now that's only a certain types of sampling procedures that will do that, okay? Now random assignment means that once you have your sample, no matter how you've gotten it, you now divide them up randomly into experimental and control groups, or what's called assignment, okay? Now, with experimental research, we have three different designs. We have the pre-test, post-test control group, post-test only control group, and the Solomon 4 group. So the pre-test, post-test, what happens here is R stands for random. The subjects are randomly assigned to two groups, okay? Both are pre-tested, so that's what you're seeing here. O means observation. So here's group 1 and here's group 2, both getting an observation. But what happened is that only one of the groups got an intervention or treatment and are observed after. The other group is observed after too, but they're our control group. They didn't get a treatment. Now we also have the pre-test only control group design. And what that means is subjects are randomly selected and assigned to two different groups, the control and the experimental, and only the experimental group is treated, okay? After close observation, both groups are post-tested and a conclusion is drawn from the difference between the groups. Now with the Solomon 4 group, this is kind of a combination of the pre-test only and the pre-test post-test groups. Notice we have 4 different groups. Okay, so here's the 4 groups. We have randomization in all, and now we only have a pre-test in 2 of them and we have a treatment in 2 of them. Okay, but the treatment is not necessarily in the same 2 that got the pre-test, but all of them, all 4 groups, get a post-test. Now, here are some examples of experimental research. The effect of selective human estrogen receptor partial agonist on breast cancer. The effect of teaching with a cooperative group strategy or a traditional lecture approach on students' achievement. The effect of an educational program for RNs on the development of pressure ulcers by patients in hospitals. And the effect of isolation during COVID-19 pandemic on the incidence of depression in the elderly. Now, the statistics that we use are called inferential statistics, and I want to point out here very different than descriptive statistics because we are no longer just describing. What we are doing is making an inference or a conclusion, okay, about the data. And so the different types of statistics that we can use here are the t-test, ANOVA, ANCOVA, multiple regression, and factor analysis. Now the t-test is used to determine if there's a significant difference between just 2 groups. The analysis of variance, or ANOVA, is used to determine 2 means from 2 independent, unrelated groups. We use the F distribution for that. ANCOVA is the analysis of covariance, and it's used to test the main and interaction effects of categorical variables on a continuous dependent variable while controlling for this effects of selected other continuous variables which covary with the dependent. The control variables are called covariates. Multiple regression, that's used when we want to predict the value of a variable based on the value of two or more others. And then we have factor analysis. That's a technique that is used to reduce a large number of variables into fewer number of factors. The technique extracts maximum common variance from all variables. Now, next we have quasi-experimental research. That's very similar to experimental research, but it's missing random assignment to conditions, or it's missing a control group. And some people call this quasi-experimental research. If you're a purist with experimental research, you're not real happy about quasi, except it can be very good, and we can control in other ways by using certain statistics for the things that are missing, like the random assignment or the control group. What happens definitely is a manipulation of an independent variable. Now, the different design groups that we have for quasi-experimental research, we have the non-equivalent control group design. It's also called the comparison group, pre-test, post-test. So I will tell you about my dissertation. What I did at one school is I taught dimensional analysis to learners, and then I went to another university where they were not getting dimensional analysis. They were getting the usual intervention or usual method of teaching the research, the medication calculations, which was ratio, proportion, and the formula method. So the intervention was considered dimensional analysis. I gave a pre-test, I gave a post-test, and then I looked at the difference between the two. The time series design has neither a control group or randomization, as you can see. Now you can see this group up here did not have randomization. There's no R, okay, in the diagram. Here there isn't an R either, and we don't have another group, so there isn't a control group. What we do have, so that we can decrease the type of errors that may occur, are a number of observations. Okay, so that's what we're doing in this particular type of design, the time series. Now, examples of quasi-experimental research could be the effect of group work on final nursing course grade, the effect of the use of an alcohol-based hand disinfectant on VRE acquisition rates. The next would be, does an evidence-based practice educational intervention have an effect on evidence-based practice knowledge, attitude, self-efficacy, and behavior of the health and social health professionals participating in that education? Again, that would be a research question. And now, what type of statistics would you use in quasi-experimental? Well, the same that you would use in experimental. And so if you have any questions, please place them in the course